Hi, this is Samir. I have an interview with one of the West High School in Iowa City. Can you introduce yourself, please?
Yeah, my name's Matt Harding, and I teach physics at Iowa City West High School.
Okay. And do you use technology in your class or in?
Yeah, certainly. With the physics classroom here at West High, we have a set of lab computers, laptops that we can use for collection and analysis of data, and also gives the students an opportunity to do some simulation work as well. Those are kind of probably the two primary modes that we use the computers for. With the lab setup, the students collect the data with the goal of developing a model for a situation. And so this is a whiteboard for a circular motion model. The students collected data relating force and speed for a stopper on a string. And what I like about the technology here, the particular software that we use, is it very easily allows them to manipulate the data in order to find a linear relationship. And so in this case, although they don't quite have it diagrammed properly on their board, to get a linear graph, a straight line graph for this relationship, they have to square the speed of the object. If they're doing that by hand, it's a little bit cumbersome, and it would take the better part of the period. With the computer, it's something that they can usually turn around rather quickly. And so part of the output of this is an equation, and here you can see force equal to the slope times the speed squared plus a very near zero vertical intercept. Rather than just give them the equation, here they're using the software to help develop that equation on their own. What they'll find here through discussion in class later on today is that this numerical value here with the units kilograms per meter actually relates to something physical in the lab itself. It's a linear graph, so the constant slope usually relates to something that we held constant in the lab, and sure enough, if they take their stopper mass divided by their radius, they're going to find a value very near to this. Rather than just start from the point of, hey, the equation for circular motion is F equals mv squared over r, they can use the technology to rather quickly derive that relationship on their own.
Okay. In your class, you have many different students who maybe understand everything fast, and some of them are a little bit weak on understanding.
Certainly.
Yeah. How you deal with this together? How you develop the curriculum that fit all of this together?
Certainly, I think one of the big goals with the way that we structure the class is that there are multiple representations for relationships. So with any model or major concept in physics this year, we've got a visual representation, some kind of a graph here to show them a relationship, as well as the analytical or the mathematic relationship. So there are kind of a couple different ways of getting at that idea. When we're dealing with force, this is a different whiteboard, just some student representations of force for the same scenario. And force has a lot of issues as far as introducing that to physics students. And so there are a couple different modes of representation here. This diagram here that kind of looks like a concept map is called a system schema. And so this is a visual way for the students to identify interactions that are occurring in a given situation. And then from this visual representation of those interactions, they work towards diagramming the particular forces that the objects are exerting on one another. And this was a new representation to me within the last couple of years, but I find that, like you're saying, there are some students where if we just tried to start with diagramming the forces on the object, they'd be lost. But this is a nice concrete representation. They physically see the string connected to the stopper, and so that's evidence of an interaction there. They see that the hanging weights are attached to the string, so there's evidence of an interaction there. And then here with dashed lines, they're representing the interaction with the Earth, which we're aware of, even though we don't have direct contact to give us evidence of that.
Okay. What is the process that you usually use when you're designing your curriculum using UDL?
So kind of the game plan is to try to find multiple modes of representation for the students. I think probably when I first started, students had the impression that physics was just a set of equations, and as long as they memorized the equations and how to put the numbers into the equations, then they understood physics. And I found that they weren't understanding physics. We've got another example here, just that idea of multiple representations. And so this is a way of structuring conservation of momentum problem, which would be familiar to most physics students. But the way that we represent the conservation is through a graph. And so this particular graph has velocity on the vertical axis, and it's a bar chart. The width of the bars relates to the mass of the objects. And rather than just the standard mass 1 times velocity 1 plus mass 2 times velocity 2, here they have a visual representation of the momentum. And so the area of the rectangle represents the momentum. And the concept that they eventually get around to is that the total area of the rectangles here in the initial, before the collision or the explosion, will have to be the same as the total area here for the final, after the interaction occurs. And again, rather than just memorizing an equation, now they have a visual representation. And for a lot of learners, particularly in introductory physics, where we get a wide cross-section of learners, this is a helpful tool.
Okay. Do you use laptops or iPads in your class?
We'd use laptops a fair bit for data analysis, and we also would do some simulation work. So like when we're studying conservation of energy, there's a group out of University of Colorado Boulder that has a set of free simulation sheets called PhET. And so often at the beginning of a unit, one of the assignments for the students is to spend 10 or 15 minutes using that simulation just to try to learn a little bit and build their intuition. It's not really very guided. I just kind of set them loose for 10 or 15 minutes. And the way that those simulations are structured, the students, just through interacting with it and the different parameters that they can control, are going to have a better idea for the variables that are in play in a particular model. So if we're studying projectile motion, they start to get an idea for how changing the angle affects the motion, or how changing the mass would relate to projectile motion.
Okay. Do you think your students getting to know the physics better by using technology, or just by using the regular teaching paper and books and like this?
Sure. I think the real benefit to those simulations is that, rather than a situation where maybe we're doing a hands-on demonstration in class, I can have students working in groups of 2 on a computer, and very quickly they're going to be able to run through a lot more iterations of projectile motion than we could in class. Maybe in class we'd get through 1 or 2 demos. If they're there working on their computer, they can change the situation much more rapidly, and they can change it in much greater extremes. So that's certainly a case where I think the technology is helpful. Also, it allows you to sort of create that ideal situation that we really like in physics, where everything is frictionless and there's no air resistance. You can model that pretty reasonably with the computer. It's just important for the students to understand how that simulation varies from reality. Is it a huge variation? Is this something that isn't modeling reality at all? Or, is it really not that far away from what a realistic situation would look like?
Okay. Do you think using UDL in your class is benefiting the students who are like disabled or low understanding?
Just by the nature of the course and where it occurs in the sequence in high school, I probably, if I'm being honest, I would have to say that the students that I get are more homogenous maybe than if we looked at the whole cross-section of students here at West High School. But certainly they come to the class with different strengths. And, you know, UDL as an idea apart from the technology, I think just in the multiple modes of representation that is kind of separate from the technology, having those multiple modes of representation, visual, diagram, equation, verbal, those are very beneficial to the students. Whereas if it was a class that I taught from a standpoint of, hey, here's the equations, you know, that's a more select group of students, I think, that are going to be able to perform well in that class.
Do you think your school is moving to use the technology more and more, and they're getting to be at like a technology education?
I think it's more prevalent now. We've got a recent move in the district where they're putting a smart board and a Elmo document camera in every classroom. So the technology is starting to be a little bit more ubiquitous. That can kind of be good and bad. If teachers are just using the technology to do the same things that they were doing previously, if the smart board is just the overhead but fancier and more expensive, then I don't think we're improving teaching at all. And so that's, you know, a big area of concern. As this technology comes along, is it just allowing and encouraging teachers to do the same old things they were doing before but in a fancier way? Or is it actually enabling them to do new, better things with their students? And so that's the really important question, I think, that people should always put to teachers and administrators when they start to introduce new technology. You know, what is this allowing us to change about the way that we do education?
So you agree with me that the administration and teachers, they always need training to use the new technology?
I think that's really important, because otherwise, if you just throw it into the room, you know, I can see a case where somebody that's really reliant, you know, the type of teacher, maybe you can remember this as well, where they're just writing their notes dutifully on the overhead all period long, and the students are copying them down. You know, that's a real easy mode for someone to lapse into with a smartboard, and it's not really taking advantage of what the technology can do in that situation. With training, I think teachers will find new and better things to do with the technology, and that's really the key thing, is the training that goes along with it.
Okay, thank you very much.
Okay.
Thank you for giving me this time
Sure.
to interview you and to share this with my class.
No problem. Good luck with your training.
Thank you, Mr. Harley.